At this time, we're supposed to find the output waveform for 4-input NAND gate. Okay, so we're supposed to draw the timing diagram again. Keep in mind that anytime you want to draw the timing diagram, you're supposed to draw the dashed lines for every single waveform, okay, on this diagram. I'm going to start from the first waveform. So I have first transition over here, this time. So this is my dashed line. I have another transition over here. So I'm going to draw the dashed line. And I have another transition over here. I try to be accurate max as I can. I believe that you are going to do this much better than I do. Okay, I'm finished with the first waveform. Let's take a look at B. I have transition over here. Remember, you have to go down and you're supposed to go up. We have another transition over here from low to high, and I can say I'm finished with waveform B. I have waveform C. Transition is at this time. Okay, let me just make this more clear. Okay, so this is my transition. Remember, every transition is very important. In order to get correct answer, you're supposed to mark all of them. And we have another transition over here. And if someone is going to be very picky, can also make the transition over here. And we have another transition at this time. Again, we're supposed to look at the truth table of the NAND gate before we're going to draw the output waveform. And always remember that in order to get low at the output of any NAND gate, no matter how many inputs you have, your inputs supposed to get highs. But if at least one of them is low, output automatically become high. So let's take a look what we have over here. We have 0, 1, 1, 1. This is automatically high according to the table because we have got 0. At least 1 0 at the input gives me high at the output. We have high, 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 high. When I have all inputs high, output become 0. That's why I'm going to write over here 0, because I have high, 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 high. I have high, low, high, high. And I forgot the dashed line over here. And I have low, that's why my output become high. And I have low, high, low, high. This is automatically high. And at this moment I have high, low, high, high. Because I have low, this is also is going to be high. And I have low, low, high, high. Because I got lows, that's why this is going to be high. I have low, high, high, high. Because I have low, output is going to be high. And at this time I have high, 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 and high. All inputs are receiving highs. That's why this is going to be low. And at this time I have high, high, low, high. That's why this is going to be high. Why? Because I got 1 0. And I have high, high, low, low. That's why this is going to be high, because I got 2 zeros. And I have high, low, high, low. Okay, because I got lows, this is going to be high. Now I'm ready to draw the output waveform. I have high, I have low, and I have highs over here, and I have low over here, and I have highs. Remember, when all inputs are receiving high, output is going to be low. And I got highs at these 2 times only, that's why I got lows. And because I got zeros, remember, at least 1 0 at any input of the NAND gate will give me high at the output. That's why I get so many highs. And I can say that this is the output waveform, and this is the solution to my problem.